Hello friends, thank you for coming in No Blogger. It is second class of design pattern and today our session is Singleton Design Pattern. So first, what is Singleton Design Pattern? Singleton Design Pattern means I will create only one instance of a class throughout the entire application lifecycle. In the entire application lifecycle, I will create only one instance for a class. This is known as Singleton Design Pattern. No other extra instance will be created. Why we need this? Why I need to use this Singleton Design Pattern? Suppose I have a requirement to store the user activity details. If any user doing any activity in my web application, then I need to store the details of the user activity, means user ID, date and time, and the activity details, that what the user actually has done. That's all. It's a common requirement for every application. So now what I will do, I will write a code for, I will write a class named suppose user logging activity. Okay. So and under this class I will have two methods. One is to store the user activity details, another is to fetch the user activity details. And now suppose I am not using the Singleton Design Pattern, then what will be done? Whenever any user will perform any activity in my web application, then a new instance will be created for the class of user logging activity. If the same user performs another activity, then another instance will be created and one more memory location will be allocated. If the same user performs 30 activities, then 30 instances will be created and 30 memory location will be allocated. So what I am doing, I am allocating 30 memory spaces, 30 separate memory spaces for a particular functionality. Is it feasible? No. And that is why we are using Singleton Design Pattern, so that only one instance will be created and the 30 activities will be logged. So what the benefits we will get from this Singleton Design Pattern? We are not wasting our memory spaces, because we are not creating 30 separate instances. We have only one instance and we will just call this object again and again. Now we have the basic idea on Singleton Design Pattern, because now we know why we should require this pattern and what is this actually definition of this pattern and what the benefit I will get from this pattern. So we have the basic idea. Now we are going to the class construction part, that we will learn how to write the code for a singleton class. To write the code, we need three things. One is static member, second is a private constructor, and third, a static factory method. Why the static member? Static member will confirm us that only one memory will be allocated, only one memory location will be allocated. Private constructor will confirm us that the class will not be accessible from the outsider classes, so that someone can call it and access it. It will not be possible for outsider classes. So no one extra instance will be created by the outsider classes. It's a confirmation. The confirmation will be provided by the private constructor. And the third one is static factory method. Why it is static factory method, that will be discussed at later. I will discuss it in detail. But now we need a static factory method because we need to provide a global point of access to the singleton object. How it can be done? Just actually we need a method by which someone will be able to access the instance from the outside, and so we need to use this so we need to use this class, so we need to use this method. Now I will go to the coding part where I will learn to write the singleton class. Look, there are multiple ways or forms are available to write a singleton class. Okay, among them the simplest one is the eager initialization. First we will discuss on it. Now, what is eager initialization? Eager initialization or eager instantiation. Okay, eager instantiation means I am going to create the instance at the time of class loading. When the class will be loaded, the instance will be created. Okay, so now we will go for the code. Now we can see the code here. Public class1. Class1 is the class name, and second line is public static final class1 instance equal to new class1. So instance is the variable name and class1 is the type of the variable. So the instance variable will contain the instance of the class1 and the access specifier is private. Okay, so it is not accessible from the outside. And the static final. Why the static final? Final makes the variable constant. Once the variable assigned by a value, the value will not be changed in the future. This is the constant variable. But if I am using the final, then one problem can be arised. Each time the variable will be called, compiler will allocate a new memory location for the variable. But our motto is not to allocate more than one memory throughout the entire application lifetime. That is why we are using here the static. Why? The static will confirm the particular instance variable will not allocate more than one space in the memory. Okay, so that is why we are using the static final. So the private static final class1 instance. Now the next is private constructor. We know why we are using the private constructor, because we don't want to get access from the outside. And the third one is get instance method. Its return type is class1, so it will return the object of the class1, and it is public and static. Public means it is accessible from the outside. Let me describe the execution part. Get instance method is the only member who is accessible from the outside, so someone will call the get instance method. Okay, for the first time, when the get instance method will be called, it will call the instance variable. Fine. Whenever the instance variable will be called, for the first time, it will call the constructor. Here constructor is private. Okay. The constructor will generate an object and the object will be assigned to the instance. And the next part is the get instance method will return the object to the outside. Now at the second time, when the second time the get instance method will be called, the instance method will be called. Fine. But here the instance method is final, and final means it is constant and the value is not going to be changed, and already the instance of the class1 is already assigned to the instance variable, so the instance variable is not going to be changed further. And that is why at the second time the class1 constructor will not be fired, and so the existing instance will be returned. Using eager initialization, creation of the singleton class is very easy, but it has some disadvantages. What are those? Look, actually we are creating the instance at the class loading time, because look here, we are using the instance variable under the class1. So whenever the class1 will be loaded, the instance will be created, and that is a problem. Problem is that We are creating the instance at the time of class is loading. At that time, actually I don't know whether the object is required or not required. If it is not required, then it is just wasting of resource and CPU time. Side by side, just because of we are using the static variable to call the constructor, so we do not have the option to manage the exceptions. And it is the main problem that we have no option to manage the exceptions. And that is why the next we will come with eager initialization using static block. So here is the code. You can see the code is class 1 is the class name. Under that we are initializing one variable instance, and it is like a private static, data type is class 1, private constructor, and then the static block. Within the static block we are assigning the value of instance variable with a new instance. So this is how we can create another singleton class, and now we have the option to manage the exceptions because we have the static block, and within the static block we can manage our exceptions. But it has some disadvantages. What are those? Look, what the logic we are using behind that. This is eager instantiation. Eager instantiation means I am creating the instance at the class loading time. Okay, at that time when I actually don't know whether the object is required or not required. If it is required, then okay. If it is not required, then it is a just wastage of resource and wastage of CPU time. So this is a big issue that we are writing a code which will be a cause of resource wastage and CPU time wastage. That is why let me come with the next form, which is lazy instantiation. Okay,